Assalamualaikum students, welcome to the Phys Maths Concept. This is Shamsa Jabin and we are solving Cambridge IGCSE Paper 6 062562 May June 2025. In this video, we will solve the question number 3 of this paper. Let's start it. A student investigate an image formed by the converging lens. Okay, where the student switches on the lamp, then we have placed the distance d 20 centimeter 80 centimeter from the illuminated object. So here you can see we have the converging lens, we have screen, we have illuminated object, and then in the screen obviously we get the magnified inverted sharp image of the illuminated object is formed on the screen. Figure 3.1 shows the position of the lens when the image is sharp. Okay, so basically we get a sharp image in this position. Now what they want from us, they want in the figure 3.1 measure to the nearest 0.1 centimeter the object distance x. So this is our x distance and we need to measure it, the center of the lens to the illuminated object. So how we will measure it? Everyone have the ruler and we will just use the ruler. Place the ruler over here. Wait, I will make some space. Clear. Okay. Now place the object. Place the ruler in this position and find out the distance. This one and this one, right? And when you measure it, it will come out to be 4.1 centimeters, right? Okay, so the next part, figure 3.1 is drawn to the scale of 1/5 full size. So calculate the actual object distance. So actual x, capital X, must be equals to 5 times of small x, right? Substitute the values. 5 multiplied by 4.1, it will give you the answer 20.5. Okay, now B part. The student continues to move the lens away from the illuminated object until a second sharp image, which is diminished and inverted, is formed on the screen, right? Second image is formed. Measure to the nearest 0.1 centimeter. Again they measure the distance and it comes out to be 59.8 centimeters. Okay, now see what they want from us. In the first part, they ask you show figure 3. Shows the illuminated object. Okay, on figure 3.2, draw a diminished inverted object in the space provided. So here we need to draw the image, right? So it is clear from the inverted one, it is clear from the inverted one that it is inverted, and from the diminished means it must be smaller in size. So I think I should draw a more smaller image, this one, right? Inverted means up, like we can invert, and then diminished means small. Okay, now come to the calculate the value d, that is equals to y minus x. So students, just substitute the values. We know that, I think we move to the y value is 59.8 and the x value is 20.5. Just substitute it, we get the answer. 59.8 minus 20.5 will give you the answer 39.3, right? The focal length f of the lens can be found by using the equation this, right? Value of the use the value of d from A and d from B. I think I should use the other color. This is given, and we should use the value of d from A and small d from BII and calculate the f1 focal length of the lens. Okay, small d is given, capital D is also given. I think should use it. Let's substitute the values. F equals to d square. D is mentioned in the question, that is 80. This one, 80 whole square minus 39.3, the smaller d we calculated in the above part, divided by 4 times 80, and it will give you the answer 15.2 centimeters, right? Now move to the next part. The students repeat the experiment procedure in A and B for an object to screen distance 100 centimeter. This time capital D is 100 centimeter and it records the values. These are the values that are given. Now calculate the second f2 of the focal length of the lens. Again we need to find out focal length. Use the same equation. So I am again writing it d square minus d square divided by 40. Okay. So I am writing the formula, capital D square minus small d square divided by 4d, right? So capital D here in this case is 100. 100 square minus small d is 63.7 divided by 4 into 100. It will give you the answer 14.85, or you can say that 14.9. E part, two quantities, wait, I will use the, yes, are can be considered to the equal within the limit of experiment accuracy, and what is that one? 10% of each other. If the value is less than 10% of each other, it means then the both values are, we consider them equal. So state whether your values of f1 and f2 from part C and D can be considered equal or not. So how we will find that we will consider them like equal or not? For that case, we have the formula for the percentage difference of values. Right? Here we have the focus length. So we can say that percentage difference of focal length F. I am just writing the short one. F equals to F larger minus F smaller divided by F average multiplied by 100. So we get the answer is percentage. Okay, so what is F average? I think I should change the color. Yes, I am explaining you what is F average. So focal average value of focal length is F larger plus F smaller divided by 2. So what is F larger? 15.2 plus 14.9 divided by 2. It will give you the answer 15.05. Just substitute the values. We know that the F larger is the previous one, this one 15.2, right? F smaller is 14.9 and F average is 15.5. So it comes out to be 15.2. Okay, wait, I don't want to write it in the lines because I give the explanation. Okay, say it comes out to be 15.2 minus 14.9 divided by 15.05 multiplied by 100. So it gives you the answer 1.99%. And this answer is basically less than 10% of the values, right? So it means the values are equal. So what statement we need to give? Since percentage difference in F is percentage difference of F is less than 10%, I think I should write less, is less than 10%, both values of F are equal. Is it clear? Students, if you have any doubts or any confusions, you can comment me. I will reply back to you. Okay, now move to the next part. State one technique to use when doing this experiment to ensure that the image on the screen is focused as clearly as possible. So what we need to do for getting the focused image, we need to move the lens slowly, right? In this case, we are moving the lens backward. So how we will resolve it? By we should give the statement. It's a 1 mark question, so you should write, for the focused image, move the lens backward and forward slowly, right? So move the lens slowly. Okay, this experiment is usually done in dark room. Explain how this makes it easier to see the images in focus. Okay, so if we have a dark room, better contrast between the image and the rest of the screen is visible. So we can say that the better contrast between image and rest of screen. Okay, students, I hope this question will be clear. We will get back to you. I will get back to you in the next video with the next question. Thank you. Allah Hafiz.